Did you know that every single smart answer you get from ChatGPT effectively drinks an entire bottle of fresh water and consumes 10 times more electricity than a standard Google search? We are currently witnessing 15 of the most breathtaking AI discoveries in history, from simulating entire worlds to programming living cells. But behind this glittering curtain of artificial intelligence, an energy monster is waking up. A monster that could push our power grids to the brink of collapse. Is the future already here? Yes, but it's thirsty and it's expensive. But why have we fallen into this trap? Let's look at the numbers the tech giants don't want you to pay too much attention to. To understand the scale of what's happening, we have to look at the engine room of the AI revolution, the data centers. These aren't just rooms full of computers anymore. They are industrial-scale power plants of information. According to the International Energy Agency, IEA, we are on a collision course with reality. By 2026, the electricity consumption of AI and data centers is projected to double, reaching a level equivalent to the total power consumption of the entire nation of Japan. Imagine that, one single technology branch requiring the same energy as the world's fourth largest economy. This isn't just a gradual increase, it's a vertical spike. We are in the middle of what analysts call an inhumane arms race. Every time NVIDIA releases a more powerful H100 or Blackwell chip, the efficiency of the software goes up, but the demand for total power skyrockets because we are training models that are trillions of parameters large. It's like building a car that's 10% more fuel efficient, but then deciding to drive it 1,000% more often. The net result? A massive energy deficit. This explains the frantic, almost desperate moves we're seeing from big tech. They aren't just buying software companies anymore, they are buying the grid. Microsoft recently made headlines by signing a deal to resurrect a unit at 3 Mile Island nuclear plant. Think about the irony for a second. A software company from Seattle is now the primary financier for reopening a nuclear site just to keep its servers humming. Google and Amazon are following suit, pouring billions into small modular reactors, SMRs, and direct power purchase agreements. Why? Because they know that in the very near future, the winner of the AI war won't be the one with the best code, it will be the one who owns the most plugs. They are Rousseate, frantically securing energy islands to protect themselves from a public grid that simply cannot keep up. When we talk about the cloud, we often think of something weightless and ethereal, but the reality is heavy, hot, and humming with high-voltage cables. These hyperscalers are essentially building a parallel energy infrastructure. While the world discusses carbon footprints and green initiatives, the Silicon Valley elite are quietly cornering the market on baseload power. The logic here is purely macroeconomics. If you control the power, you control the compute. If you control the compute, you control the intelligence. And if you control the intelligence, you control the market. But as these giants hoard gigawatts of electricity to train the next version of GPT or Gemini, what happens to the price of the power used to light your home or run a small local business? We are seeing a massive shift in how capital is deployed. The billions that used to go into user experience or interface design are now being diverted into cooling systems and massive transformers. It is a brute force approach to progress. We are literally burning the present to calculate the future. This scale is overwhelming. It's hard to wrap your head around a data center that requires its own dedicated nuclear reactor. It feels like science fiction, but the contracts are already signed. The physical limits of our planet are finally catching up to our infinite ambitions of our digital dreams. But is there a way out of this energy trap, or are we destined to build a digital god that burns down its own temple just to function? Surprisingly, the answer might lie within our own heads, or at least in chips that try to mimic them. Amid the darkness of energy waste, Intel and MIT are lighting a beacon of hope with brain chips. But can a single star save a sky that is already on fire? To understand the solution, we first have to understand the fundamental flaw in how computers work today. For decades, we've relied on the von Neumann architecture, a system where the processor and memory are separate. Data has to constantly travel back and forth between them. In the AI era, this shuttling of data is exactly what creates the heat and burns the gigawatts we just discussed. It is inefficient, slow, and increasingly unsustainable. But what if we built a chip that worked like the biological masterpiece inside your skull? Enter neuromorphic computing. Leading this charge is Intel's Loihi 2. Unlike traditional chips that stay on and consume power constantly, Loihi 2 mimics the way human neurons communicate, through spikes. In your brain, a neuron only fires when it has something important to say.
The rest of the time, it stays quiet, conserving energy. When applied to AI, this results in staggering efficiency. We're talking about optimization tasks where Loihi 2 is 100 times more energy efficient than the world's best CPUs and GPUs. Think about that for a moment. If the energy monster we described earlier could be shrunk by 100 times, the global energy crisis sparked by AI would virtually vanish overnight. And Intel isn't just playing with prototypes. They've built Holopoint, a massive system containing over 1,100 of these Loihi 2 processors. It simulates 1.15 billion neurons, roughly the complexity of an owl's brain, while consuming a mere 2,600 watts. To put that in perspective, that's about the same power used by a high-end electric oven, yet it can perform 15 trillion operations per second. So, if the solution is right here, why aren't we seeing Loihi chips in every Tesla, iPhone, and Google server farm? Why are we still bailing out nuclear plants instead of just switching the silicon? This is the Loihi paradox. The problem isn't the hardware, it's the language. Our entire digital world, from the Python code used to build ChatGPT to the CUDA kernels that run on NVIDIA chips, was written for traditional processors. To use a neuromorphic chip, we can't just port the software. We have to rethink how we program intelligence from the ground up. It's like trying to run a high-speed train on a cobblestone road. The engine is brilliant, but the infrastructure isn't ready. Furthermore, there is a massive economic moat protecting the status quo. NVIDIA didn't just win because they have the best hardware. They won because they built a software ecosystem that millions of developers have spent a decade learning. Switching to brain-inspired computing requires a global relearning phase that most corporations aren't willing to pay for, at least not yet. But as the cost of electricity begins to rival the cost of the chips themselves, the math is changing. We're approaching a tipping point where being smart isn't enough. AI has to be efficient to survive. However, even if we solve the energy problem with these miraculous chips, we still face an even deeper, more uncomfortable question. In a world where intelligence becomes ultra-cheap and hyper-efficient, who actually reaps the rewards? Does a 100-fold increase in efficiency lead to a 100-fold increase in human well-being? Or does it just accelerate a financial shift that leaves the majority behind? To answer that, we need to step away from the circuit boards and look at the flow of money. We need to look at the Cantillon effect of the AI era. To understand the real danger of this energy crisis, we have to move away from the circuit boards and look at the flow of money. We need to look at the Cantillon effect of the AI era. In economics, the Cantillon effect suggests that when new money, or in this case, a new wealth-generating resource like AI, is injected into the system, those closest to the source benefit first and most, while the rest of the population sees the cost of living rise before they ever see the benefits. In the AI era, that source isn't just data, it's electricity and compute. Think about it. As we've discussed, the massive energy demand of AI is driving big tech to corner the market on power. When Microsoft buys an entire nuclear plant's output, or Google secures gigawatts of green energy, they aren't just buying fuel, they are building a moat made of energy. This creates a brutal filter for the economy. If you are a small startup with a brilliant AI idea, you're no longer just competing on talent or code. You're competing on your ability to pay the electricity bill. When energy prices spike because the local grid is struggling to keep up with a nearby data center, the hyperscalers don't blink. They have the capital to absorb the cost or own the power source outright. But for the small player, the costs become prohibitive. The result is AI is rapidly becoming a luxury good for the elite. We're moving toward a world where only the top 0.1% of corporations can afford to train and run the most advanced models. The democratization of AI we were promised is starting to look more like a consolidation of power. And here's where it hits home for you. As these giants hoard energy, the secondary effect is a hidden tax on everyone else. When the demand for transformers, copper, and baseload electricity skyrockets to feed the AI monster, the price of building a house, running a local hospital, or simply lighting your living room starts to climb. You are effectively subsidizing the training of a digital mind that might eventually automate your own job. This is the ultimate irony of the 2026 AI landscape. We're seeing companies like Coworker.ai generate millions in revenue with just a handful of employees. That efficiency is incredible for shareholders, but it's a poverty premium for the rest of society. The wealth generated by AI doesn't trickle down. It gets trapped in the silicon and the power lines of the companies that own the infrastructure. For the young professionals watching this, the 25 to 45-year-olds who are the backbone of the current economy, this is the wake-up call. We're entering a winner-takes-most cycle. If intelligence is power, and power requires energy, then the ones who own the plugs will own the future. We often talk about AI as a tool for human progress, but we have to ask, which humans? Are we progressing toward a shared utopia, or are we just accelerating a system where the average person becomes an obsolete consumer of an intelligence they can no longer compete with? This isn't just about technology anymore, it's about the fundamental restructuring of wealth. And as we push the limits of what our planet can provide to fuel these digital dreams, we are also pushing the limits of our social contract. But there's one more layer to this. It's not just about the money or the power, it's about the very survival of our species.
Because while we are busy calculating the ROI of a new data center, AI is beginning to make discoveries in a field that could either save us all or create a new set of problems we aren't prepared to handle, the very code of life itself. This brings us to a chilling realization. We aren't just restructuring wealth, we are restructuring the very definition of human value. In the world of high-speed AI, the concept of average is effectively dying. Look at the breakthroughs we're seeing in medicine. We've mentioned how AI is slashing drug discovery times from 5 years down to a staggering 18 months. It's a miracle of science. But let's look at the hidden cost. To find that one life-saving molecule, AI models have to simulate trillions of biological interactions, running 24/7 on high-performance clusters that generate enough heat to boil a lake. Here is the ethical paradox. We are using the finite resources of our physical environment, the energy, the water, the rare earth minerals, to fuel a digital sprint towards immortality. We are effectively trading the habitability of our children's planet for the speed of our current medical breakthroughs. Is a pill that cures a rare disease worth the carbon footprint of a small city? It's a question no one wants to answer because the answer is uncomfortable. We are entering an era of technological triage. Because energy is no longer cheap and compute is no longer infinite, we have to decide what AI gets to solve first. Does it go towards curing cancer, or does it go towards generating hyper-realistic deepfakes for social media? Right now, the market decides, and the market usually chooses whatever generates the most clicks, not the most cure. This leads to a deepening divide in human health. If AI-driven medicine requires massive energy and capital, who gets the treatment? We are risking a future where the elite have access to AI-optimized, personalized longevity, while the average person struggles with rising energy costs in a healthcare system that can't afford the electricity bill to run the same diagnostic tools. We are accelerating so fast that we've left our moral compass in the dust.
We have the jailbreak and the breakthrough, but we don't have the regulation. We are programmable, our biology, our thoughts, our economy, but we haven't programmed a safety net for the soul. As a financial analyst, I see the ROI on these medical startups and it is astronomical, but as a human, I see a looming Minsky moment for our environment. We are borrowing against the future to pay for a now that we aren't even sure we can control. The future isn't just a destination anymore, it's a high-stakes trade. And every time we celebrate a new AI discovery, we need to look at the ledger. We need to ask, what did we give up to get this? We've talked about the monster in the grid, we've talked about the consolidation of wealth, and we've talked about the death of the average. The question isn't whether the future is here, we know it is. The question is whether we can afford to live in it. So where does that leave us? Are we just spectators in our own displacement, or is there a way to reclaim the narrative before the grid goes dark? It's time to look at the big picture and decide what kind of intelligence we actually want to build. So here we are. The AI revolution isn't just a series of headlines or a list of 15 cool discoveries. It is a fundamental shift in how our world breathes and consumes. We've been told that the future is wireless and weightless, but the truth is far heavier. Every breakthrough, every world-simulating model, and every AI-designed drug comes with a bill paid in gigawatts, in fresh water, and in the concentration of power among those who own the grid. The future is indeed here, and it is irreversible, but for it to be a future worth living in, it must be sustainable. We cannot build a digital utopia on the ruins of a physical world. Intelligence shouldn't just be about speed, it must be about responsibility. As we move through 2026, the lines are being drawn. You have to decide where you stand. Will you be a blind consumer of this digital convenience, ignoring the cooling fans humming in the background? Or will you be among those who understand the true cost of a click? I want to hear from you. Should there be an AI energy tax to protect our public grids? Or is this just the unavoidable price of progress? Let me know your thoughts in the comments below. Let's start a conversation that actually matters. I'll see you in the next analysis. Stay sharp and stay informed.